So today I'll be presenting the status and the trends of PV technology in Canada. So I'll present the trends in the PV market. As you may know, the market has changed tremendously in the last 5 years. It's very different than what it used to be. Also talk about the PV industry, talk about the general mood, but also give hard figures on economic indicators as number of jobs, capacity installed, numbers of modules sold. I would like to thank many of you who have participated in my most recent survey on the solar cell R&D capability. This is the 4th edition now, and the report is not yet published, so I will get back to you soon to just give it a quick last look before it gets published. But nevertheless, I'll present some of the highlights of the report here. And finally, the market is changing, evolving very rapidly. As the price of PV systems in Canada is decreasing, there's new opportunities to be seized, and thus I'll present the current deployment framework in Canada. So let's start with a broad overview. Let's start with looking at the photovoltaics internationally. Last year, there were about 28.4 gigawatts of PV installed capacity, mainly in Germany, in China, and Italy. So this represents a growth of 42% over the previous years, which brought the total cumulative installed capacity worldwide to just below 100 gigawatts. So as the capacity of PV is increasing worldwide, so does its contribution to the global energy mix. We take a look here at the figure from a very interesting report from the International Energy Agency. We've now reached, since last year, a global energy mix that's now above 1% in 8 countries, meaning that PV electricity now contributes more to 1% to the national energy mix for these 8 countries, from Italy to Belgium, no, even more, to Australia. So these 8 countries have a contribution above 1%, which is indeed impressive. And even in Germany and Italy, we can now reach 5% of the national energy mix. So PV is growing, and it's going to soon be, if it's not already on the radar screen of utilities, I'm sure it will soon become very noticeable. Just for information, Canada is somewhere here, and we're at about 0.2% for the moment. But there is hope. We'll be moving closer to the 1% landmark, that's for sure. Now, if we look at the technology market trends, we're talking about all kinds of technology approaches, very interesting. There's a lot of competition between the concepts. Right now, the established technology is, of course, crystalline silicon. Its market share has been decreasing for a number of years, down to 70% in 2009. But since then, China has put in place a large manufacturing capacity in crystalline silicon technologies. So that has allowed crystalline silicon to grow back its market share to about 87%. Whereas Germany, the US, and Japan used to be the superpower of solar cell manufacturing, they're now far behind China, which produced 53% of solar cells in 2011, according to the IEA, and which produced 62% of the modules in 2011. Now, in terms of thin film technologies, the largest producer is First Solar, which produced 1,981 megawatts of cadmium telluride PV modules in 2011. Something that's interesting to bring to your attention is that there's now CPV cell production that's at the level. So there's production, at least in the US, in Germany, France, Australia, and I know there's also some production done in Canada, but it's starting to appear as an emerging technology. Now, if we zoom in on Canada, go back to Canada, last year there was 268 megawatts of installed PV capacity. That represents a 48% growth over the previous year, and established the cumulative capacity now to a total of 766 megawatts. So that's a large growth. Up until 2008, the the photovoltaic market in Canada was dominated by off-grid applications because these applications are already cost-effective. But starting in 2008, we started, the grid-connected applications became more important than that off-grid market. And that's thanks to the support of the Ontario Power Authority that put into place a number of incentive programs over the year. The first one was the RESOP. The current ones are the feed-in tariff program and the MicroFIT programs. These programs provide an incentive, an amount of financial incentive for the production of renewable electricity. So, and that's done over a contract that's set for a period of 20 years. So with regards to photovoltaics, these incentives range from 34.7 cents for large ground-mounted centralized applications, and they go up to 54.9 cents for small rooftop applications. Now this price schedule was reviewed last year in July 2012, and the prices were adjusted or decreased by about 10% down to 31%, depending on the applications, and that was to ensure the sustainability of the program, and also to take into account that the cost of PV systems and components have been decreasing year after year, and that decrease has been accelerating. As we can see here, PV module costs have decreased by about 84% in the last 10 years. It used to be $7.14 per watt, and it's now down to an average of $1.15 per watt. So that represents the average, the weighted average of the price you would pay if you go to a distributor and ask to buy a PV module. Certainly, if you're doing large-scale applications, you might get better prices than that. I've seen some, even for retailers, 85 cents per watt. But in all of Canada, over average, was $1.15. And now the modules, which used to represent about half the cost of the system, are representing about almost 1/4 or even less than within the price of the system. So with regards to installed grid-connected PV system cost in 2012, the average was $2.80. That's for a large centralized power plant, and it goes up to $5 per watt for a small residential system, 10 kilowatts and less, installed on a rooftop. Now, there again, that can vary from region to region. If you go in remote communities up north, you can expect to pay between $10 to $12 per watt for a system in the Yukon, a small residential system. But nevertheless, we see that the price of module is decreasing very fast. And now the soft costs, like the installation, the profit margin, and the permitting costs, are representing a larger share of the total installed PV system cost. So there's some improvements to be made in this area. Now, the fact that these costs are decreasing so fast, that's spurring the growth of the installation of PV capacity everywhere in Canada. If we leave Ontario aside for a moment, we see that even in markets where there's no incentives, the growth can be observed. In BC, there's 2 megawatts now installed. In Alberta, about 2.1 megawatt. So, and it's growing everywhere. In Quebec, I used to be one of the first 10 residents in Quebec to have a PV system on the house. Now there's 41, and last time I heard there's another 60 applications being notified. So, even there, it's increasing. But of course, all this capacity is dwarfed when you look at Ontario, which really which represent 99% of the grid-connected capacity in Canada. There's more than 15,000 solar homes in Canada that have ground-mounted or roof-mounted systems and can benefit from solar electricity. And that capacity is just the beginning. It's the capacity that was in operation in 2012 at the end of the year, 759 megawatts peak. But there's other additional capacity being put in place, being developed. So we can expect that by the end of 2014, the installed capacity in Ontario will surpass the 2 gigawatt mark, will be around 2,348 Now, of course, there may be some cancellations in there, but nevertheless, I'm confident that we'll go above the 2 gigawatt landmark. Now, that's for the short-term trend, the next 2 years. What will happen in, let's say, 5 or between 5 and 10 years from now in Canada? What can we expect to see? Well, according to a report published by McKinsey, these consultants forecast that there will be still some price decrease for crystalline silicon modules. We can expect a further 40% decrease in the price between now and the end of 2019, mainly due to efficiencies made in productivity, procurement, incremental technology improvements. So all these factors will have to bring down the cost further. Now, in parallel to this, the retail price of electricity in Canada keeps on increasing. If we look at how the price for these different markets, how the price has increased since 2006, between 2006 and 2012, we see an average increase of about 20% in Canada, with a low of 2% for Montreal and a high of 37% in Vancouver. So the price of PV is decreasing, the price of retail electricity is increasing, so we're getting closer and closer to the point called the grid parity, defined as the point where the price of electricity, of PV electricity, can compete with the retail price of electricity. So it's not a question of will we ever get there, will we ever be competitive against conventional means of generating electricity. The question becomes, when will we reach grid parity? And my next 2 slides attempt to give an answer to this burning question. So we have here the analysis, the scenario. I've put in yellow the dots, which represent the actual price, the retail price for different markets, different large cities in Canada, along with their solar PV potential. So the solar PV potential in this case is defined as how many kilowatt hours per year can you generate with a 1 kilowatt system. So if you install a 1 kilowatt system, 7 square meters of PV modules, crystalline silicon modules, let's say in Edmonton, you can expect to generate about 1,250 kilowatt hours per year. And if you install that same system, let's say in St. John's, then you can expect at most maybe 940 kilowatt hours per year. So these are the prices. Now the lines represent the price of PV electricity based on the levelized cost of electricity. So that takes into account all kinds of figures, the depreciation of assets, taxes, degradation of the modules over time. Everything is taken into account. So there again, the price of PV electricity will depend on the solar resource at a location. If you are in a location where there's a lot of sunshine, then the price of PV electricity is lower than if you are, let's say, in a location with low sunshine resources. So as we see, as we move closer to, as the price, as we've read in the McKinsey report, we decrease the cost of this system again for a number of, let's say, 8% per year until 2020. We see that in Canada by 2020, most of the markets in Canada will have reached grid parity. So that's, we can see that point coming on the 2020 horizon. If let's say, if something happens and the price does not decrease as fast, if we use half the price decrease that we used to observe, let's say 5% per year, then we're more between 2020 and 2025. So we know that it's coming. With regards now to remote communities, I was saying that the price of a PV system in Yellowknife, for example, is about double the price that we have here in Ontario. So we need to do another scenario in that case, because there's also lower sunshine potential in some of these northern locations. The price of the system is higher. On the other hand, the price of local electricity is also higher, especially in those communities that rely on diesel generator to produce the local electricity. And what we see in those markets is that already in 2013, some of these markets have already reached grid parity, and some others are coming fast towards a grid parity. So that has inspired some provincial governments to put in place some solar vision, some objectives to reach. And as such, the government of the Northwest Territories aims to install 1.8 megawatt by 2017, so that the solar systems will supply about 20% of the average load in Northwest Territories diesel communities. And that's, we'll be working with them, looking at the performance assessment and making sure things are going well. We'll be devoting some efforts on helping them reach their objective within the next few years. So I say this is a very interesting and important milestone that we are in the process of achieving. Certainly that's good news for the industry. And the industry had a relatively, I would say, tough year last year. We've just received an analysis from Navigant that surveyed 46 companies, 12 distributors, and 13 manufacturers. And the general mood there was that in 2012, the delays associated with processing the MicroFIT applications and the launch of the FIT 2.0 somewhat slowed down the market a bit. As for manufacturers, the delays in obtaining environmental approvals for centralized projects and the decrease in module pricing also affected their business very much. So in general, I think everyone is affected to a large extent by the global oversupply of modules. I mean, the consumer can benefit from that over the short term, but nevertheless, it's a big adjustment we need to make. And even though, I mean, generally speaking, the trend last year was very positive, but there were some, I would say, some hiccups on the way. Now, in terms of hard figures, there's 650 solar companies operating in Canada at the moment. A few closed shops last year because of this aggressive competition that's taking place right now with regards to modules. The industry is now worth about $730 million. These are preliminary estimates. They could be refined in the coming months as we get final data. And this solar PV industry is employing about 3,320 people, mainly in the manufacturing sector. Speaking of manufacturing, we have at least now 10 module manufacturers, all operating from Ontario. Last year, altogether, they produced 460 megawatt of PV module. That's the estimated production numbers. But the potential production is close to 1 gigawatt. So they can certainly face the additional capacity. They can meet the demand with regards to the additional capacity that will be installed between now and the end of 2014. Now, if we move to the R&D activities, solar cells, so there's now at least 40 university professors that have received funding to carry out solar cell research in Canada. They are at 20 universities, and altogether, if we count highly qualified personnel, the research assistants, the lab technicians, this amounts to about 400 to 450 full-time researchers focusing solely on solar cell development. I did not include, Andreas, your activities on solar buildings in this, so that's only focusing on solar cell development. This research is done in a wide range of topics, ranging mainly from organic, dye-sensitized solar cells, 3-5 compounds, thin film technologies, crystalline silicon, and many novel concepts are being investigated and presented here, actually, in this conference. Solar cell research is mainly supported by NSERC, that invests $4 million per year in this topic. And also, provincial funds also provide help. CFI funded 6 projects in the last 3 years, and McMaster University was a large recipient of the CFI funding. So you'll have a chance actually on Friday to visit the solar lab that was in part supported by CFI. And finally, SDTC also co-funded 4 private projects dealing with solar cell development between 2008 and 2011. On the federal level, there's a fundamental work done on organic PV and 3-5 cells. I'm sure some of that work has been done in collaboration with some of the professors here in this room. So I'm presenting the process of finalizing the layout of the report. It will soon be available on our website, and I will get back to you in the coming weeks to give a last look at the report before I publish, to make sure that your profile is well in place. Now, as for research done at the Canadian level, the federal level, that's where I'm from, our mandate is to do research that will facilitate the deployment and the development of PV in Canada. So we tend to be, this is very much fundamental research, applied research, but nevertheless on solar cells, whereas our activities range more at the other end of the spectrum. Once the technology is produced, I don't care if it's thin film cells or dye sensitized or quantum dots. Once we can install it in the field, it will need to be, I would say that we'll need to develop standards on performance, on safety, and so on. So that's what we do. We chair the Technical Committee 82 that develops standards on PV systems and components, the Canadian subcommittee, I would say. We also develop information, collect information to to assist the development of appropriate policies. But more specifically, we work on projects that can help to remove barriers. So at the moment, we're talking a lot with utilities about high penetration PV in electricity grids. It's becoming an issue in some locations in Ontario. So we want to really, first of all, quantify the solar variability and see what kind of solutions we can install on the grid before we export the problem to the grid. So that's something we focus on these days. Also, the performance optimization of large utility scale PV systems. This is a new application in Canada, large systems. So we are developing a methodology to identify losses and quantify them and see, okay, where is it worth to devote efforts to improve the performance. Finally, I'd like to bring to your attention that we've worked with Environment Canada to look at the environmental performance assessment of PV. So we conducted an evidence-based study with them to quantify and also develop a qualitative assessment of the potential benefits and impacts of PV systems on the environment, taking into account all the life cycle stages, so from manufacturing, operation and maintenance, and decommissioning. So we're looking at different environmental figures, merits, energy payback time, looking at the GHG, and also landscape. So in order to answer some of the questions that are starting to arise as PV capacity is being deployed, and we're seeing more and more PV in our Canadian landscape. And of course, we compare these figures with other technologies to be able to make some relative comparison. So as I understand, the report is now ready for publication. It's being reviewed at the high level right now. So it should be published sometime this year. And once it becomes available, I'll send a link to the PV Innovation Forum so you can take a look at this. So that's pretty much sums my contribution. If we just look at the general trends, PV system costs are decreasing, and we can see now the grid parity over the 2020 horizon, 2025 maximum. Now, as we get towards that objective, we'll see that there's the need to address the grid integration of the technology will become more and more urgent, and also the need to integrate PV on net zero energy buildings or high performance building is also a trend that's developing. Buildings, they don't necessarily have to wait until we reach grid parity. Buildings are not power plants that generate electricity at the cheapest price. Buildings have an aesthetic value, they have a functional value, and so integrating PV is a worthwhile choice, just as integrating another cladding material. So within that perspective, there is a need to also develop solutions for the integration of that technology to energy efficient buildings. So thank you very much for your attention.